Hey guys, I'm live. How you guys doing? I think it's time for a math lesson, so let's do it. Here we go. All right, I'm take off where take uh take from where we take off from where we last left. Okay, so we proved before last time I did a calculus video, a math video. We proved that dy dx, if y equals sine x, then dy dx equals cosine x. Sometimes x is called theta for an angle. We proved that last time. So let's go from there and do some more calculus. That's okay. By the same method as we did before, and just switching a few of the details around, we can also prove that if y equals cosine x, then dy dx equals minus sine x. So the derivative of the sine is the cosine, and the derivative of the cosine is minus the sine. We can prove that without too much. I mean, that's provable, just like we did with proving the derivative of sine x. So let's take it a little step further and say we want to do the derivative. If y equals the tangent of x, what is dy dx? We could use the definition of the derivative for this, which we could say dy dx equals the limit as h approaches 0 of tangent x plus h minus, I didn't have limits enough room, so let's write it underneath. We can prove it this way. We go dy dx equals limit as h approaches 0. I can barely read my writing. Limit of tangent x plus h minus tangent x all over h. We could do something like that, and then work that out. It's really be a pain though. And why not do it an easier way, which I'm going to show you guys. Let's do it. The tangent is defined as in a right triangle. The sine of let's say this is h. Sine h equals opposite over hypotenuse. So it's this length divided by this length. And cosine h equals adjacent over hypotenuse. So the cosine is this part over that part. And the tangent equals the opposite over the adjacent. So it doesn't have the hypotenuse in its equation. It's this height here divided by this length here, O over A. So what we can do is a little mathematical trickery. If tangent equals O over A, and sine equals O over H, and cosine equals A over H, then we can say tangent x equals sine x over cosine x. Use that little guy to help us out. And why is that true? Because sine h, I should say, I said h here. I meant to say sine h. I called it h here and x there. In fact, I shouldn't say the h. I shouldn't use h as an angle because it makes it look ambiguous here. I'm going to write sine x and cosine x. So x is the angle, and O over h is the opposite over the hypotenuse. Cosine x is the angle. Cosine is a over h, adjacent over hypotenuse. So tangent x is sine over x over cosine x. Why is that? Because sine of x is O over h divided by cosine inverts the cosine, so that would be a. No. Invert that, which would be h over a. And the h's can't, and it's times. The h's cancel out, so that's equal to O over a, which is what I said it was. So that's cool. So we can do it like this. We can go, since we want to know the derivative of the tangent of x, let's write that, rewrite that as y equals over a sine x over cosine x. And so we want to know that. I mean, we have that. So we want the derivative. We want what is dy dx? What's the derivative of the tangent? Well, since the tangent is sine x, so the tangent of x is sine x over cosine x. We want the derivative. We want dy dx of sine x over cosine x. What is that? That's our question. Well, there's something called the quotient rule. You take the bottom one, so you get dy dx. Take the bottom one, which is cosine x. And what's the quotient rule again? Thought so. Okay, quotient rule is the bottom one times the top one. So cosine x times sine x. Yeah. Minus the verse of that, which is sine x over. Wait. Goofish. I goofed here. Okay, the quotient rule. We're going to use the quotient rule to do the derivative of sine x over cosine x. So what that is you have cosine x times the derivative of sine x. That's what you have. Then minus. I don't have enough room. Let's write it up here. That's maybe I'll have a room if I do it up here. So by the quotient rule, we have dy dx equals cosine x times the derivative of sine x minus sine x times the derivative of cosine x dx, all over cosine squared x. That's the quotient rule applied to this. You take the bottom one, cosine x times the derivative of the top one, minus the top one times the derivative of the bottom one, all divided by the bottom one squared. So we're going to try to find the derivative of that. That's easier than just using the definition of the derivative with the tangent directly. This is easier. All right, let's do this. This is dy dx. So we want to know. Let's see, derivative of sine. we're going to simplify this. That means this dy dx equals what? Well, you have cosine x times the derivative of the sine of x, but the derivative of the sine of x is cosine x. So that's just another cosine x, so you get a squared, cosine squared x. And then minus this thing, sine x times the derivative of the cosine x. Well, the derivative of the cosine x is minus the sine of x. So that gives you times minus sine x. The minuses can't, oh, and it's all over not like that. Like this right here. This is all over cosine squared x. So the minus signs cancel out, and the sine squared, the sine x times the sine x makes the sine squared x. So that's equal to cosine squared x plus sine squared x all over cosine squared x. I think I did that right. Yeah, let's do this. Okay, that looks right to me. Somehow I did it right. No error there. Let's figure out what this is. So what is cosine squared x plus sine squared x? Well, in a circle, if ever you have so you got this, you have a hypotenuse here, and then you got x, y, and I'll call this I will call it h. So what you have is this, that the equation, if you make this is the terms you're using. The equation of a circle is every point that is a hypotenuse away from the center, i.e. this is the radius, and every point that is that far from the center is on the circle, which makes a circle because every part of the circle has that same radius or distance from the origin, or the center, they call it, or they call it the origin. But what is true of this triangle here is a right triangle. And what's the Pythagorean theorem say? Pythagorean theorem says that x squared plus y squared equals h squared for a right triangle. This is a right triangle right here. So the equation of a circle becomes x squared plus y squared equals h squared, which is the radius. And since that is true, then we know that cosine, cosine, let's write it up here. Well, let's not erase that yet. We know what, I need room. So let's just keep it in our minds. Till I come back to love you, keep me in your mind. It's a Scorpion song. I'll think of the name of it later. So if x squared plus y squared equals h squared, and x over h equals cosine h, and y over h equals sine h, then you can see that since the equation of the circle is x squared plus y squared equals h squared, x squared x squared plus y squared equals h squared. X x equals cosine h times h, I think. And y equals sine h times h. And h is equal to h. But if x squared plus y squared equals h squared, let's keep that in mind. If x squared plus y squared equals h squared, then we have x squared, x is this, so x squared is cosine squared h times h, x squared, cosine h times h, squared. You can't just leave it as h, it's squared, because cosine h squared plus times h squared. And that's x squared, so then you add plus y squared. Y squared is sine squared h times h squared. I don't need to write it like that. I'll write it like that. Cosine squared h times h squared plus sine squared h times h squared. And then according to the Pythagorean formula, Pythagorean theorem, that is all equal to h squared. So it's x squared, which is this, plus y squared, which is that, equals h squared. We'll divided both sides by h squared, and so what you can do, and the h's cancel out. I'm going to divide everything here. H squared divided by h squared, and this divided by h squared, the h squareds all cancel out. So you get cosine squared h plus sine squared h equals 1. And voila, this is x instead of h, but the same thing. Either one's the variable, is the variable at hand. Cosine squared h plus sine squared h. We just showed that cosine squared h plus, cosine squared x plus sine squared x. What is that? We just showed that cosine squared h plus sine squared h equals 1. Hx doesn't matter, so this up here is 1. Because cosine squared x plus sine squared x equals 1. So then what we have, dy dx, and that is if we started with a problem, if y equals tangent x, then dy dx equals this, which is 1, over that, which is cosine squared x. So the derivative of the tangent x is 1 over the cosine squared x. But the cosine equals 1 over the secant. Cosine x equals 1 over secant x. Secant is the inversion of the cosine, and cosecant is the inversion of the sine. So if cosine x equals 1 over secant x, then this dy dx equals 1 over cosine squared x. Since it's 1 over, this is 1 over the cosine squared x, but cosine, the inversion of the inversion of cosine squared x is secant squared x. So since the 1 over cosine squared x is equal to secant squared x, and that is the derivative of the tangent x is equal to the secant squared x, because cosine x equals 1 over secant x. Just trig again, it's a trig definition. Should I got that right? Sure did. Okay, I just proved that what the tangent of the derivative of the tangent is is the secant squared. So the derivative of tangent theta is secant squared theta, or derivative of the tangent of x is secant squared x. So that's the proof of a little more trigonometric calculus. Are we tired? Do we want to stop? Or do we want to do a little more? Or do we want to just, let's see. I don't know. Do we want to keep going? I'm going to make an executive decision to break this up further into sections rather than do all of this and have a 3-hour video. So what we're going to do is call that the lesson. I have 2 more lessons planned and ready to go. First of all is a lesson on something called the chain rule. And then the second lesson to come is a lesson on something called implicit differentiation. We'll do those as the next 2 math lesson videos. So love you guys. Peace, love, and rock and roll.